Okay, welcome back. Here we are with number 3. By the way, I just noticed that someone scrambled up the letters of pre-calculus and wrote curl capsule, but that should say pre-calculus, not the anagram. Okay, so we want to look at the end behavior. And end behavior, that really asks a question, what happens in one of two things. As x gets very big, x gets bigger and bigger and bigger, goes to infinity, and also as x goes to negative infinity, so all the way to the right or all the way to the left. And it really depends on the leading term, because for large values of x, the exponent is really what determines the size of the show. So here, for this first one, the leading term is negative 2x to the fourth, and the 4 is an even degree, and the leading coefficient is negative. So we can immediately see what's going to happen. That imagine x is a very, very big number. X to the fourth is going to be huge, but then we're multiplied by negative 2, so it's going to go down here. And if x is a big negative number, x to the fourth is still huge and positive, but multiply it by negative 2, we also get negative infinity. So we'd say the end behavior is that f of x goes to negative infinity as x goes to infinity. And let's put a box around that. And f of x also goes to negative infinity as x goes to negative infinity. And those are called the end behavior, and that's the function 21. Let's move over and try out function 22. And we have to really think about general form. If we had it in general form, we could just pick off the leading term. And thinking about that, we want the leading term. We actually don't need any other term. So if we multiply this out, this is in factored form, partially factored form, we would have f of x would be x squared times 2x cubed minus x squared times x plus x squared times 1. And here's the leading term, and that's all that we need to know. And it's simplified, that'll be 2x to the fifth, and so that's an odd degree. And there's a positive coefficient. So what this means is that two things: as x goes to infinity, well, x to the fifth will get bigger and bigger and go to infinity, and 2 will just make it twice as big, so f of x will go to infinity. And then as x goes to negative infinity, 5 is an odd power, so x to the fifth will be negative but very big, times 2, it'll be twice very big but negative, and so we'll have f of x goes to negative infinity. And so that's called the end behavior there, and so we get a slightly different graph. It'll go up in one direction, down in the other direction. By the way, over here on the left side, end behavior doesn't say anything about what happens in between. We know that polynomials are continuous functions, so these two ends have to connect, and so something interesting happens in there, and that's the subject of another problem. Let's leave it here and head on to number 4.